number 8 in this problem set about power series from a professor at Princeton University. These were past exam problems, supposedly. This is a very typical interval of convergence problem. This one asks for what real values of x, this summation as n goes from 0 to infinity, -1 to the n, x to the n over n squared plus 1 converge. Give your reasons. So whenever it asks for interval convergence, even though it doesn't explicitly say it, it's asking for all values of x in which this power series converges. That's interval of convergence. Okay. So to find the interval of convergence, we first need the radius of convergence, and that is always with the ratio test. Technically, you can use the root test as well, but typically use the ratio test. Okay. So we do the ratio test of limit as n goes to infinity, a sub n plus 1 times a sub n plus 1 divided by a sub n. So that's the setup right here. Okay, x to n plus 1 divided by x to n. Subtract the power, so you're left with x to the first power. So that doesn't depend on n. We can pull it out in front of the limit. And then we're left with n squared plus 1 on top and an n plus 1 quantity squared plus 1 on the bottom. If you expand the bottom out, it'll be n squared plus dot, 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 dot. Who cares? It's like a rational function. We take the degrees. They're both the same, right? N squared on top, n squared on bottom, the biggest degree, I should say. So we take the ratio of the leading coefficients, which is just 1 over 1, which is 1. That's why this limit is absolute value x. By the way, when you move that x out in front, you can't drop the absolute value. Okay? For it to converge, the ratio test says it has to be less than 1. The result of the limit has to be less than 1. Now we start solving this inequality. So -1 is less than x, is less than infinity. Not infinity. Why am I saying that? 1. Okay? So by the way, the radius of convergence is 1. And then we start solving the inequality. Now, because remember, the ratio test is inconclusive when it's equal to 1. That's at these endpoints. We got to check the endpoints manually. So we check x is -1. What do? We plug in x is -1 into the original series right here. Okay, so -1 to the n times -1 to the n, that changing sign cancels out because there's 2 of them, right? So you're left with 1 over n squared plus 1. This, hopefully you have some intuition that this should converge, and you could do a limit comparison test or even a direct comparison test, because 1 over n squared plus 1 is less than 1 over n squared for n greater than or equal to 1. And since we know this converges, this series, since it's smaller, also converges by comparison test, okay? We check the other endpoint x is equal to 1, so we plug in x as 1 over here. 1 to the n is just 1, so we could omit that. So it will be -1 to n over n squared plus 1. This is an alternating series. We can do the alternating series test. We take the limit as n goes to infinity of without the changing sign, that's 0. And this is what, I don't know if the professor is super picky, but I would be if I were the grader of this test. You have to show that it's a decreasing sequence as well. Remember, that's a condition for the alternating series test. One of the 2 conditions. So that's why I took the derivative, and then you get this, and then you can clearly see that it's negative for n is greater than 0. Okay? Therefore, this series converges by the alternating series. By the way, why did I check the derivative is negative? Remember, this is Calc 1 or the previous course. When the derivative is negative, the function's decreasing. So that's why. So we include both endpoints. So the interval of convergence is -1 less than or equal to x less than or equal to 1. And that's our answer. So once again, to recap, interval of convergence, you always do the ratio test first to find the radius of convergence, and you start solving with the inequality, and then you check the endpoints. Okay, that's the procedure. There's a couple more of these that are on this problem set, so I'll go over them as well. They're all pretty typical, so you should know how to do these in my opinion. All right. Hopefully this is helpful. If you needed a refresher or just learning for the first time of how to compute these radius and interval of convergence, please give this video a like if it helped you in any way. And also hit that subscribe button if you want to be notified for the other radius and interval of convergence problems.